Hello guys, welcome to this new video. So in this video we're going to see interpolation technique in QGIS. We'll also see how to calculate areas of different interpolated classes. Okay, so at first I'm going to import my shapefile on which I'm going to interpolate, or it is my study area boundary. Then let's add our XY point data. So you can add comma delimited Excel files here. So I find that sometimes a bit problematic. So I have installed one plugin which can handle Excel files easily. You don't have to convert your file into comma separated one. Okay, so to do that, you need to go to this plugins, manage and install. Okay, so right here you can see my installed plugins spreadsheet layer, this one. So I need to just here type as here spreadsheet. So it will pop up here and you need to just install it. That's it. So I have just installed it. After installation, when you go to this layer panel and then add layer, you'll see one new spreadsheet layer icon. Okay, so just click on it and now browse to your Excel file. Okay, this one is my data. So now here you can see it may be unchecked, it may remain unchecked at the first time, so you need to check it geometry. Then X field will be your longitude, okay, and Y field will be latitude, and you can see the preview of that. And if you find any different, like let's say for example you can see something is integer but here they are telling you that it's a string, then you can also convert that into integer. Okay, that's it. So okay, oh, I have forgotten to say one thing, that geographic coordinate system. Let's do that again. Right here you can see the reference system, so I'm keeping that as WGS 1984 and code is 4326. That's it. So now it's time to do IDW. So let first see nearest neighbor technique, that is Thiessen polygon one. So to do that you need to go to this raster, I guess, yeah. Then analysis and you'll see here nearest neighbor. Okay, so here we're including our sheet, that is our XY coordinates. Okay, then we are going to leave everything as default. Now the Z field is going to be, I have many water quality parameters, so let's say we are going to interpolate calcium concentration, and now you don't have to touch anything else. Now if you would like to save this file in a folder, so you can save that, save to file, whatever you want, but I'm not gonna save that, and you need to give it a name. Okay, but I'm not going to save it. So if you don't save it in a desired file or folder, then it will be removed after you close your QGIS interface. Okay, so run it. Alright, so it's successfully done, our Thiessen polygon one. Okay, now let's see how can we do using IDW one. So IDW and then IDW interpolation, this one. Okay, so this is our sheet, Excel sheet. Interpolation attribute is our calcium data. Now here you need to check that, just click on this plus icon. Okay, our vector layer here, leave everything. Oh, here you have something to do, extend. You can't leave that empty. So you can say and draw on canvas, or you can give it the extent of your shapefile for shadow. In this case, in my case, it's for shadow, but it's not going to work the way we want. Now it's very important rows and pixel size. Let's say we are keeping it by default, so let's see what's the change if we don't change it. Now run it, close it. So you can see our just change the color, go to symbology and what pseudo color. Okay, let's say spectral one. So you can see not much difference, like just three different colors here, three or four different colors here, because our pixel size is very big. That's why. So we need to and we have three rows, three columns, so we don't have much data in it. We have same amount of data, but we are just using a higher, very large area to show just one single data. So let's do that again. Before that, I'm just going to delete this one. Okay, IDW, interpolation, calcium, then okay. Now extend. Okay, let's say I want 150 rows. That's it. Okay. Now run it. You'll see significant change close. Now you can see it's something you have intended to do. So go to properties and now do pseudo color. Then let's say okay, color is this one. Okay. Now apply. So you can see we have some 5 classes different. Now you can, by default it's linear interpolation technique. You can do discrete one, apply. Now you can see it's a bit familiar one, I guess. Now I don't know how to remove this ugly appearance, those spikes, but I can do that in ArcGIS. In QGIS I don't know. If any one of you know that, please let me share that in the comment section down below. Okay, so let's go to properties again. Now you can classify it if you want. You can see here classify continuous, let's say quantile, and now you can change the number of classes, let's say 10. Okay, apply. Now you can see 10 different classes, but you can also manually change them. Here let's say you want 10 first one, then second one till 200. Okay, 200. Why isn't it working? I don't know. Let's do that again. Quantile. Okay. And let's say it's 0 to 100, and it's 120. Let's say it's 130, and it's 200. Okay, now apply it. Okay, so now you can see it's now in your manual range, so you can manually change that also. Now the question is, which one is better, Thiessen polygon or inverse distance one? So Thiessen polygon works, it's actually a clustering algorithm, nearest neighbor. So it just works as calculates nearest pixel values. So using the nearest pixel values, it creates one polygon, while uh, IDW creates a weighted system, like the point surrounding your station are going to have much more weight than a distant one. So researchers suggest that if you have sparse data points, then Thiessen polygon is a better option. But if you have dense data points, then IDW or Kringing is okay, good, fine. So that's it. Now, if you want to calculate areas of each of those classes, let's say you want three different classes. So how can you do that? Now to calculate area, oh, at first let's clip it for our study area. So this one is my study area. So I would like to clip it, clip the raster for this zone, clip. Now we need to check this one, I guess. Clip raster by mask layer. Okay. So here it will be your interpolated map. This one. The mask layer is your shapefile. Okay. Now here the important one is target CRS, target coordinate system. In my case, my UTM zone, actually, my UTM zone is UTM zone 45 north, and I don't know what is in your case, but if you don't know, you can find that by just Google searching, or you can go to this QGIS and you can easily find that. Sorry, not QGIS, it's Google Earth Pro. You can see Bangladesh lies in two UTM zones. One is 45, other is 46. Now to have that, you need to go to this tools, then options, and check this universal transverse system. Okay, then apply it. Then you will have this one. Now it's in the north side, this Bangladesh. So that's why 45N. You can see this one is north and this side is south. Okay, so let's go back to our QGIS. So here my zone is 45. You need to, sorry, what am I doing? Yep. Now to find your one, you need to go to click here. I've already. Then you can search here. Here you can search it. Let's say UTM45. Here you can see we have UTM40. How is it? Well, you can yeah, 45. So you can find this way, I think. Yeah, searching to search it a bit. Then okay. Now, is there anything else that I can do? No, just clip it from. It's done. So now let's remove other layers for sanity. Alright. Yeah. Now you can again uh, just to do a bit of coloring. Okay. Now to calculate area, you need to reclassify it at first. Reclassify by table. Raster analysis. Under raster analysis, you have to reclassify by table. Then click here. Check your clipped mask. Then reclassify table. Reclassification table. Click here. Add rows. I need three rows because I need to classify it in three different classes. Let's say 0 to 40 our first class, and unique value is 1 for that. You can do whatever you want, but that should be a integer. So now 40 to, let's say, 80 is going to be second class. Then 80 to, let's say, highest 189, so let's say 190 is class 3. That's okay. And this one isn't matter, you will, it's like our value should be greater than the minimum value and less than or equal the maximum range value. We'll get that in a minute. So is there anything else? No, I think it's okay. So run it. Yeah. All right, now reclassification is down. Now we don't need all these layers. Okay. Yeah, just remove them. Okay, so now if we right click here and go to, we don't have any attribute table right now. So now if you would like to create, sorry, if you would like to calculate area of each different classes, you need to have attribute table, but we don't have any attribute table. So we need to create attribute table, we need to transform this raster into a vector. Okay. Before that, just let's go to symbology and do a bit of styling here. Okay, apply. Okay, now you can see 3 different classes. Our 1, 2, 3. Okay, and so now to do raster to polygon. Polygon, yeah, raster pixels to polygon. Vector creation. I think yes, this is. Uh, so this is our reclassified IDW, then band 1 field name. What is this field name? Oh, they will create new one, I guess that's why. So run it. Oh, I think I got the wrong one. Close, remove. Yeah. Our layer tools extract. Raster analysis maybe. A polygon raster to vector. This one raster conversion. Sorry. So I need to be careful about it. Here it is raster conversion, polygon to, sorry, yeah, raster to vector. Okay. So everything is same. Here dn is just new field name. Okay. Run it. Close. Now you can see we have successfully created one new layer, vector layer. Now if we go to this attribute table, you can see we have this attribute table and we have this dn new one. So 1 is our first class, 2 is second class, and 3 is our third class. Now the only problem here is that they created different polygons for each different boundaries. You can see here. You can see this one selected. So now if I calculate area, so it will calculate area for each of those different polygons. Okay, so we need to dissolve all these things. Let's say for example we need to dissolve all the ones, just we need to accumulate all ones at the same polygon. All twos, we need to dissolve all twos at the same polygon. All the polygons which have dn2, we need to dissolve them. So now it's time to dissolve. Dissolve. Okay, so now we're going to use this dissolve one under this vector geometry tool. Okay, and before that you need to unselect everything. If there's anything selected, your result will be only on that selected layer. Okay, so make sure that nothing is selected. Okay, just go to dissolve. So this is our vectorized layer. Then click here, and we need to dissolve dn values. We don't want multiple 111, we just want single one. Okay, or single two. Okay, so right, close it. Okay, now we have new layer dissolved, you can see here. So right click here and go to attribute table. Now you can see we have 1 2 3. We don't have multiple now 1 2 3. Okay, so now you can select them easily. You can see this is 2 second class and this is third class. So now again, now we need to calculate area, the final stage. So to create area, you need to click here. You can see, yeah. So create virtual field. They will create one new field for you, and the name will be area, whole number, or you can say decimal points. That is floating point, and the code for that is dollar sign. That's a bit PHP type. Dollar sign area. Okay, area. Okay, so you can see preview here. Okay, now you can see we got areas in meter square. Now if you want area in kilometer square, then you need to create another field and just divide area by 1000, I guess. Yeah, so that's it. That's all you need to do to perform IDW in QGIS. I think it's way too much work compared to ArcGIS. So I would recommend you to use ArcGIS. At least if you are using this, you are going to do this IDW or interpolation things. That would be way more easier. You don't have to reclassify, sorry, you don't have to dissolve that again, and you will have your attribute table in the reclassification map. So that's it for now. I think you find this video helpful. If you have any questions or suggestions, anything, you can say in the comment section down below. I hope I'll see you in my next video.